Hello everyone, welcome to Profound.js, the future of open source development on IBM. My name is Alex Roydman. I am with Profound Logic. And in case you're not familiar with Profound Logic, at Profound Logic we make modernization and application development tools specifically for IBM developers. That's all that we concentrate on. And today's webinar is on Profound.js. This is our Node.js framework that makes development on IBM super easy and also helps you modernize your code. So to begin with, let me start out by telling you what Node.js is, but I'm not going to give you a dictionary definition. Instead, let me tell you what Node.js is so that I can relate it to you as an IBM developer. So, in my opinion, Node.js, it is the most exciting IBM technology ever. The most exciting thing ever to be brought onto IBM. And I feel that it brings the platform forward like nothing else ever did before. And the platform with Node.js will never be viewed as legacy by anyone again. So that's my definitions. And one more bullet. In many shops, I feel like it's going to save IBM. I say that because as I interact with customers and companies in the IBM community, I've seen many times companies try to rewrite their RPG applications or move to another platform. And these efforts have always failed, actually. The things that I've seen, maybe there's some successful ones out there, but the ones that I've seen have been failures. And the reason that they attempt to do this, it's for two reasons. It's because of outdated green screens, and it's because they're having a hard time finding developers to work on their applications. And I don't just guess that these are the problems. This is something that we at Profound have actually, we've surveyed our customers. We've surveyed a number of companies in the IBM community, and the survey shows that these are the two main concerns in the industry. And Node.js has the potential to address these concerns perfectly. It is the perfect solution. So what is Node.js? Coming back to the definition, it's server-side JavaScript. So you may have heard of JavaScript being used a lot in web applications and browser applications, traditionally as a client-side language. Well, Node.js is the concept of using it on the server side as well. And JavaScript, let's talk a little bit about that in case you're not familiar with it. It's a very powerful and popular language. One of the things about it is it's pretty simple. So when I first started learning JavaScript, I was kind of impressed as to how quickly I was able to understand it, be productive with it. It was easy for me to create functions, variables, work with data. So it's a very powerful language. It's also portable. It runs on anything, on any kind of platform, and of course now on IBM. And it's also a language that you'll just find everywhere. So if you're looking for examples, if you're trying to learn, or if you're looking for open source or any kind of education, it's out there. It's easy to find. It is the most popular language that is out there today. So if you can look around at statistics, GitHub has some statistics in terms of what is the most popular language in terms of usage, commits, activity, and JavaScript it's not only is it at the top of the list, but the usage for JavaScript in total is greater than all of the other languages combined. One of the interesting things that I have in here is that it's perfected for use by browsers first. So in the very beginning, maybe when it wasn't so stable, it really had to become stable because the web had exploded, and so the browser vendors had to really perfect JavaScript. One more point is JSON. So if you're getting into web services or REST services, that's a very big thing now, that's very popular. Well, JSON is the format that we use to exchange the data. And JSON stands for JavaScript Object Notation. That means that you're basically using JavaScript as the interchange format. If you're using any other language and you have to process JSON, there's extra work that you have to do. But in terms of JavaScript, it's inherent. It is in the format of JavaScript already. It's a language that's interpreted, which I personally like because, as you'll see me when I do my demos today, it's simple in the fact that I type my code, I save it, and I launch it immediately. There's not a compile step in there. And it is now considered to be very stable, very performant, great for production. If you look at go back 10 years ago, JavaScript was not considered to be a language that was, a very performant language. But it's very different now, and it's used by many big companies. I've got some examples here, but really, and this example is a few years old now because nowadays Node.js is just embraced by many, many companies, and they're running things in production, and there are millions of transactions that Node.js can handle. And of course, now Node.js is on IBM. But the one thing that I want to point out is that it runs in pays, just like any of the other open source technologies on IBM. This is something that runs in pays, which is a separate system within IBM, separate from your traditional applications that are ILE applications, so separate from RPG, COBOL, and CL. But the neat thing about Node.js is that really it does not have to run in its own silo, and it can truly act as if it were an ILE language and can run under the same stack and environment as your RPG applications. This is very different from many of the other languages, from many of the other open source technologies like PHP, for example. So let's answer the question, we say Node can act as an ILE language. How can this happen? What is different about Node? Well, it really goes down to the design of Node. Node.js was built as a language that was something extensible and adoptable. So unlike other languages, like if you take RPG as an example, RPG has a lot of built-in capabilities. It's great at business applications that do database transactions, for example. Node.js doesn't have that built in. You start out with a blank slate. So it's multi-purpose in a sense. But there are all kinds of packages that you bring in depending on the capabilities that you need. And so they've made it specifically expandable by these packages. So let's talk about how the packages work. There's a whole ecosystem called NPM, or Node Package Manager. It's a tool that ships with Node.js, and it is also a repository or a public registry of packages. The way that they're designed is that you're never recreating the wheel. Even the smallest type of thing you're going to be able to find on NPM. These packages often depend on each other, so even the creators of the packages are reusing other packages as they develop the packages. But you as an end user can also use these packages just as well. When you're trying to use them in a production application, you've got all of these choices for packages, but you want to know how reliable is a package. Well, the great thing about this is that there are stats on each one of the packages that really help you answer that question. So there's kind of the social aspect to NPM. So you can go out there and you can find the package, and then you can see who are the contributors, who's commenting on it, how many downloads are there. And so you're going to be much more comfortable using a package that's got 1 million downloads versus one that's got, let's say, 5 downloads. So that's a pretty important aspect of this system, NPM. I mean, NPM is amazing, and let me just kind of give you some information about it and some staggering statistics. So first of all, there are so many packages, and there's basically, if you can think of it, you can probably find it on NPM. I was working with a customer recently who was asking me, is it possible to do OCR, optical character recognition, on IBM? And basically, I went to NPM and I found my solution, and with just a few lines of code, I was able to integrate optical character recognition with their RPG applications, and I did that through Node.js and NPM and Profound.js. So there's different packages. These are things like if you look at image generation or even email, these are things that you had to perhaps buy some software. Back in the old days, you'd have to buy some software to implement this type of functionality. Well, now all of this is open source, and you could take advantage of it through NPM. So now down to the statistics. There are today more than 500,000 packages, and I think more than 600,000 or so packages that are out there available for you to use. That's a huge, huge number. And another huge number, and I think this is now even more, there are 3 billion downloads every single week of these packages. That just tells you how huge this ecosystem is, how big this is. So let's answer the question now. How can Node act like an ILE language? Well, we talked about how NPM provides a package for everything. Well, what if there was a package that made Node.js act like an ILE language and provided all of the capabilities of RPG? And by the way, at Profound Logic, We love Node.js and JavaScript, but another language that we really love is RPG because it's really great for business. It's so easy with RPG to go out and, let's say, fetch some information from a database, and on the next line of code you can present it to the user, and then you can update. All of those things are pretty simple. RPG works great with data. Well, what if we brought all of those capabilities over to Node.js? How powerful would that be? That would be super powerful. So if there was a package that provided all of those capabilities and made the learning curve for RPG developers just a matter of hours or days instead of months or years, that would be amazing. And guess what? This is reality because that's the package that we're talking about today, Profound.js. So Profound.js is just another NPM package available on NPM. It's free just like most of the packages, so the package itself is free. But there's more to our offering. So there are three pieces that we're going to talk about today. So there's the Profound.js Framework. The framework itself is the free piece. There's a lot that comes with it. But then we also have some commercial pieces. The commercial pieces are the connector and the converter. The connector is something that gives you more connectivity options, or the ability for your RPG to talk to Node, and your Node to talk to RPG, and your Node to talk to System API and to talk to the database. So some better options for that. And then there's the converter. The converter is the ability to actually convert RPG to Node.js. And actually not just convert. There's really, the name doesn't serve it justice because you're not just converting, but you're also modernizing the code as you're doing it. And as far as the usage here, it can be used to just learn Node. If you're coming from an RPG background and you want to learn Node, so you can use the converter to get some code converted and learn about it. Sometimes it's just you're going to target which programs are you going to convert, and then we also have customers that have decided this is their direction and they're converting their entire systems over to Node. Of course, that's a longer term project if you're going to do that. Okay, so let's go over some of the details. What comes with a framework, what comes with a connector, and what comes with a converter. So the framework, we talked about how it's a free NPM package that gives Node.js RPG-like capabilities. One of the things that it gives you is top-down transactional programming capabilities. So if you've ever got into JavaScript programming or into Node.js, you've run into what they refer to as callback hell, where you got to use these events or callbacks to do a lot of the I/O. And that's not as convenient or simple for most developers, so everyone is trying to look a way to simplify this. So we give you a way where things are more procedural. So if you're truly writing business application, this is the preferred way, and you can use our technology to do things in a procedural manner. There's also support for all of the IBM data types. So JavaScript by default comes with what they call primitive data types, just a few simple data types, and they're basically loosely typed. JavaScript doesn't actually enforce those types. Well, we give you all of the IBM data types. So now if you have an amount, you can make sure that character data does not go into that amount. It can be declared as a decimal field or a packed field or whatever you need. So all of the IBM data types are supported, including some of the more advanced stuff that IBM has. Of course, with the IBM data types, we have various API to work with these data types. And then there's also built-in support for user interfaces. So we have different types of user interfaces that you can display. The most common one is this rich display. The rich displays are maintained in a visual designer tool. And this makes development of applications super easy. This particular tool comes with the free NPM package. And it's a browser-based tool that comes with hundreds of widgets, and it's a matter of dragging and dropping to create your interfaces. And you put it together very much like a traditional display files in terms of the concept. So you still have record formats, you still have grids that are subfiles, and you load them in a similar way that you're used to it if you come from an IBM background. But everything is graphical, everything is web-based. It's no longer a green screen. There's no limitations. It's not really connected to a green screen in any way. The connector then is the piece, that's the commercial add-on that just gives you better capabilities of how you connect to the database, to your program. So one of the big things is, how do you connect to the database? We give you all kinds of options here that you don't normally get with Node.js. So record level access is one of them. So being able to do a similar type of thing that RPG can. So for example, chain to a record or update a record on the fly. So that's record level access. Of course, we also provide SQL capabilities, full SQL capabilities. And in addition to these capabilities, there's support for Things like overrides, so these are IBM concept or QTemp or local data areas, things like that are supported by our ability to access your DB2. Then there's the ability to seamlessly call any IBM program, any IBM command, and to pass parameters. And this even works if your program is interactive, meaning you can, from a web environment, call a green screen program. It will automatically render it in HTML for you when you use this process through Node.js. And again, all of this happens in an ILE environment within the connector. And it works in reverse as well. So not only can you call program, but your Node.js can be called directly by other RPG programs, other CL programs, and it has object level authority built in. It can receive parameters both by value and by reference. And of course, even if you're calling it from like a 5250 environment, it takes care of all of that. Even interactive programs will work with this. You can also call any system API, and the call is just like calling a simple JavaScript function, and any service program procedures work in the same exact way. So now let's talk about the converter. The converter is super exciting. It is converting RPG to Node, and not really just converting, but modernizing it. So one of the main aspects of the converter is that we've made it extremely accurate. So our goal here is that when you do a conversion, you can turn around and run that code immediately, and it runs the same as the RPG did. And we've brought in all of the concepts over to Node so that the inputs and the outputs are exactly the same as the way that RPG would handle it. So the accuracy is very important here. One of my customers have come to me and kind of said, well, this to me feels like a more holistic version of free format RPG, because that's kind of what the syntax ends up looking like. You know, it has RPG concepts, but it's JavaScript, and you have, beyond the capabilities of RPG, of course, you have access to everything that NPM can offer, everything that JavaScript and Node.js can offer. So it's like combining the best of both worlds. When you are converting, it's not one of those cases when you convert one line of code and when you see some other converters and they'll generate like 20 lines of equivalent code just to handle things in the right way. Well, because we've brought over all of the capabilities, because Node.js is extensible like it is, we're able to maintain basically a one-to-one relationship, and that's approximate, that's not exact, because in certain cases we actually simplify code and we even make it so that you end up with less code than what you started with. Now, these previous points are not nearly as important as this one right here, and that's the fact that this will also modularize your code, and this is what we're all looking for. Like, we want to modernize our code. A lot of us have these big monolithic programs. Let's say it's a program that has 5,000 lines of code. Well, wouldn't you want to break that up into, let's say, 20 components, the 20 components that actually this program consists of? Well, to do this manually would take a ton of effort, and we have a process that does this automatically for you. And when I do a demo today, you will see exactly how this is done. Some of the other benefits is that you can find and remove dead code. So if you think about it, over time your application has changed a lot, and there may be some sections that are no longer being used or called. The converter can find that for you and automatically remove it. It can also create, so out of those little components or modules, when we modularize the code, we can create REST API out of that automatically. So normally, if you were to do that manually, basically take a big monolithic program, break it all up, and then wrap it with services, that would be a ton of work. Well, now you can do this with basically one run of the converter, and it creates all the assets for you that you need. And I want to point out that what we use is an agile approach, meaning that you can do this in an incremental fashion. So it's an agile, incremental, stepwise manner. And the reason for that is because all the dependencies work. So if you think about the way your system is put together, if you have a bunch of programs, they're not really all independent. They're all calling each other. So program A calls program B, and program B calls program C, and so forth. And when you convert something with the Profound.js Converter, because it maintains all of those dependencies, you can convert just one program in the midst of all this, in the midst of this big system, and it will still continue to function, and all the dependencies will continue to work. So whereas if you were doing a manual rewrite or really any other approach, you would have to basically convert all the dependencies, and each little task becomes a big ordeal, and you can't really be agile about it. So one of the next things that I'm going to do is I'm going to actually show you a live demo of everything. But before I get to that, I just want to introduce you to some of the code and how the coding works within the system. So first of all, how do you put together a program? What does a program look like? Well, here's what an empty program looks like. It's basically a function, and then you have to export the function as a runnable program. So that exports.run says, oh, that's a program that I can actually execute and run. Now we have a similar concept here that I'm going to go over where, well, what if you wanted to create something that's similar to a service program or a module, where it's just a bunch of functions, and then the one that you want to export is the one that you export at the bottom. So this is pretty much standard Node.js syntax, but I'm just trying to get you familiar with it as we go through this. Now, what about what's the equivalent of subroutines or subprocedures in a program? Well, that's basically taking a function and putting it within another function. So that's all there is to it. That's how that would work. What about display files? So here I'm comparing your RPG code to what it would look like in JavaScript or Node.js code. And basically, we have the same capability to declare a file, except we're using JavaScript syntax. So instead of an fspec, and here I'm showing an example in fixed format, we're using a define display method, and that method points to a JSON file. So that JSON definition is what you would have built in that visual designer that has all the record formats and all the grids and everything like that. And then there's properties. Keywords, what used to be keywords, are now just going to be properties in a JSON object. So that's how that works. So that's what the syntax looks like. And then rich display files is one of our capabilities, but you can also use HTML. So if you wanted to use an HTML template, there's the ability to attach that to any of the record formats. So you've seen how you declare a display file. Well, how do you use one? So things are, the syntax is a little bit more object-oriented. So you're basically going to say, here's my display object. What is the record format? That's a property of that object. And then the method. So and you can it's very readable. You can see what this is trying to do. I'm clearing a subfile. I'm showing you how to write to a subfile, and I'm showing you how to execute a record format. So these are very much like RPG stuff, but there's things that we can do that are beyond even what the traditional RPG has done. So for example, loading subfiles quickly. Here's a method where we got 2 lines of code. We've got a query line that brings in a bunch of records from a database all into one object, and we add all of those records to the subfile at once. So these are just shortcuts that are really neat. Okay, so let's move on to database access, or in this case, doing database access with record level access operations. So you see the RPG at the top, and down below you see the equivalent. So our define table allows you to basically define a table very similar to the fspec. And you're in the JSON there, in the configuration, you're specifying what type of file it is. Is it readable? Is it updatable? Can you write to it? Can you delete to it? Is it keyed? And there are many other properties that you can specify. All of those are documented, and you can look them up. And then that becomes an object, and the object has methods. So you can do a position to, that's equivalent to a set lower limit, or you can do a fetch next. That's like doing a read in RPG. So here's an example of SQL. So in this particular example, we are allocating a statement, and then we are fetching from that statement. So you can see what the syntax looks like. But as we mentioned earlier, there's also the simpler way of doing it, where within this one shortcut method, we call it query, you can actually grab a bunch of records all within one line of code. So different ways of doing the same thing. Next, let's talk about the strong typing, the IBM data types that we've brought. So in RPG, if you declare something, let's say with a dspec like this, the equivalent here is going to use our define method, and within the configuration there you can specify the type, and you can specify any of the other properties. So if this was maybe a character field, you would also specify a length. So that gives you the strong data types. You will see why those are important in a moment, but I just want to point out that you can also do traditional JavaScript data types as well. You can do primitive data types as well. So if you wanted to use your regular vars, there's nothing that stops you from doing that. So these are just extra capabilities that we're giving you. So beyond just simple IBMI data types, you've got all kinds of advanced data types as well. So we've got pointers, you've got data structures, concepts like the system data structure and the information data structure. All of that is there, or overlays. Here's an example of what those look like. Now, the reason these data types are so important is because it simplifies integration so much. So here's an example of what if you were to call an IBMI program and you needed to pass some parameters. Well, whatever those parameters are, you just define them with the right data types. Now that Node.js can understand packed and fixed length field and so forth, you can just declare those and you can pass them in and you can pass them out. And this works when the value the value can either be by value, so the parameter can be by value. The parameter can also be by reference. So that's pretty capable here and very simple in terms of how you call programs, and it's in the same way if you want to call a system API or one of your service program procedures. I've also got an example of calling a command. So you can call a command, and please note that in this example, that's an interactive command, and that's fine. It can execute interactive command, and the interface will actually come up, and you can interact with the work submitted job command in this particular example, and then come back to the Node.js side after that. So with that, let me jump into actually demonstrating some of these capabilities live. And I've got two demos prepared for you. One is going to show you how to do new development. So new development from scratch. I think that will be very useful for you. And then the other demo is going to be a conversion demo, and you'll see what are some of the things that you get when you convert an RPG program. Alright, so I'm going to be super brave, and I'm actually going to build this first example completely from scratch, just coding everything up. So let's see, hopefully I don't mess it up too badly. So what you see over here on my screen now is basically a 5250 session running in a browser, and I'm logging in here and I'm basically getting a 5250 session. It's in a browser, and the advantage to that is that you can actually call a Node.js program that has a browser interface, and all of this will work seamlessly. And we call this capability Profound UI Genie. And the first thing that I'll do is set up the library list. So let's do edit libel, and we'll put in Profound UI and Profound.js. Those are the product libraries onto the library list. And then also my working library, and I'm using PGS samples. That's just where I'm putting my work. Of course, this is a library that could be anything. It's wherever you want to put your work when you're doing development like this. Now the next step that I'm going to do is I'm going to use the command pgs myip, and this is very neat. What I'm saying is that I'm going to say that the Profound.js server is actually running on my PC, because that's when I'm going to do my development and all of my testing, and that's running on port 8081. So by doing that, I can do all the development on my development PC, and only when things are working properly, then I'll push all of that out to my IBMI. Now my PC will be communicating with the IBMI and accessing data on IBMI, but the actual work is happening just on my PC in my development environment. So for this application, we're going to be building an inquiry over a products file, and just to show you what that looks like, let's just take a quick look with update data. So this file is, you can see that the key is product ID, and it just contains some information like product name, product description, price. And let's see what it takes to build an inquiry application over this. So let's exit out of here, and my first step is going to be to start with the visual designer. This is the visual designer that comes with Profound.js with the NPM package, and we'll build the interface. So usually I work with a much larger screen than this, so bear with me as I try to put this together. For this recording, I have to use a smaller resolution. So we're going to start out with a panel, resize that, and give it this title, Product Inquiry. And let's put some labels over here. So the basic thing that we're doing is we're prompting for a product ID, and that will be a text box. And then we're going to present to the user information such as the product description, and we'll do price, and let's display an image. Of course, we can display whatever fields that we want, but just for this example, we'll just do these three things that we're displaying. So the description is going to be a dynamic field like this, and a price is going to be a dynamic field. And then at the bottom here of the dialog, we'll put some buttons. So let's do a button like this. We'll rename this to submit, and then we'll rename this one to exit. So we pretty much got the interface, what it's going to look like, put together. And so now I'm going to go through and I'm going to put field names on everything. So actually define what things are named. So the screen, I'm going to just call it screen 1. I'm not going to be too creative, just give it some name. And let's go ahead and define what each one of these fields are named. So I can double click and give it a field name. So in this particular case, this is the product ID, and I'm specifically matching up the field names to what the fields are named in the database. So product ID, and I know that it's a decimal field, and it has a length of 5. And then we'll do product description. This is a character field with a length of 60. And then P price, and that's a decimal field. And then we'll go over to the image and find the image source property and click on the bind dialog, and so bind the image source to the field PR image. That's the field that's in my database. And the last step here will be to give these buttons a response indicator. Of course, the indicator here is not like a traditional RPG indicator where it's a numeric indicator, even though those are supported here as well, but typically you would do something like the indicator name would be submit, and the indicator or Boolean flag for the exit button will be exit. So now the screen is put together, and I'm going to go ahead and save it. So let's go ahead and save as, and I'm going to save it into my modules directory on my PC, and I'm going to make sure that I'm putting into my PJS samples directory. The directories here match to the libraries on IBM. So we're going to call this prod inq, and automatically assigns a .json extension. So now we've put together the screen, and let's start putting together the code, the Node.js code that goes along with the screen. And you can see that I didn't have to compile, I'm just saving the JSON, and that's all that we needed to do here. So let's jump into an editor. I've already set up a file called prodinq.js with a JavaScript extension, and we'll put together this code. So the first thing in putting any program together is to just set up the function and make it exportable as a runnable function like this. So we've got that, and I think this is exports like this. So we've got that in place, and we are going to then refer back to the screen that we just made, and that's done with define display. And we're going to give it an object name of display, and the name of the file here is prodinq.json. So very simple like this. And to then refer to that object, we'll use display and then dot, and it is object-oriented syntax here. So now with the name of the record format, and if you recall, we called it screen1, and then execute is one of the methods that displays the screen. Basically, coming from an RPG background, this is an execute format. Now typically when I set something like this up, I want to keep displaying the screen until the user exits the application, and that will generally looks like this. So while the exit flag is not set to true, we're going to keep on running that application. So at this point, I'm just going to save. So I press Control S to save, and I'm going to switch back to my session, and let's just try calling what we've got. So I'm going to call prodinq, and you can see that the application comes up. Now, of course, there's no functionality that we've put into it yet, but you can see that I'm able to type something in. I'm able to hit the submit button. Of course, nothing happens when I hit the submit button just yet. We're going to get to that in a moment. And then I can also exit the application. So the next thing that I'm going to do is I'm going to add functionality for autocomplete. This will be very useful because the user might not know what the product IDs are. And we can do that directly in the Visual Designer. This is something that really doesn't take any coding. It's the capability that's built into the user interface. So I can go to this text field, and then I can go into the database-driven choices, so the database-driven autocomplete choices, and specify a database name. So this is going to be products P. That's the database that we're working with, and then I can type in some options, some fields, or I can actually let's just go ahead and type them in. It's PRID would be what we're auto-completing on. That's the ID of the field. Now we can actually specify multiple options here, and let's go ahead and do PR name as well. So it'll show us both the ID and the name as the user is typing in the ID. So now that that change is in place, let's just go ahead and click Save and switch back over, and we'll try calling the program again. And so what I'm expecting to see as I type, I'm getting these auto-completed options. So let's go ahead and type another character, and I'm getting everything that starts with the characters that I've typed. So this is the auto-completion functionality. Very useful. Now, again, there's no functionality in here just yet to actually retrieve the description, the price, and the image. So we're going to get to that as the next step. So let's go ahead and exit, and we'll put in some code to actually go out and fetch a database record. So there's several ways to do this. You can do this with SQL. You can also do this with record level access. So in this particular example, let me show you what it takes to do this with record level access. So I'm going to go ahead and define a table, similar to an fspec, defining a table, but here we're doing it with the define table method. And the table name is products B, or the file name. And then as a second parameter, we'll specify some configuration options, just like this. They're specified in JSON format, and basically this is going to be a file that we read, and this is going to be a file that we read by key. So it's read true and key true. So now we've got a database table, and we can refer to this database table as products P. That's what it's called. And that will have various methods. So the one that we want is get record. That fetches a record by key. And the key that we're using is PRID. So that's all that there's really to it. So adding these 2 lines of code should fetch the record and display that record on the screen. So let's go ahead and try this again. I'll start typing, and let's just select the record. Click Submit, and I do see the description in the image. Now I made this super small. I could probably adjust this a little bit if there's room, if we wanted to make the image bigger. And I have a feeling that perhaps I either misspelled the price, or that record didn't have a price. Something like that is going on. So let's check it out. So let's choose this one. So now the image is a little bigger. Now the price, what was the name, the field name of the price? Let's just double check that, because I feel like I missed that or something. So it's PR price. I knew it, so I actually used, I think I used P price. So let's just go ahead and make that change. And you can see I'm not compiling as I work through this. I just click Save, I flip over, and I'm able to try this immediately again. So let's try it one more time. There we go. Now the prices are coming up. So that's basically it. I was able to build the product inquiry application very quickly. Now I want to show you some of the integration that I've been talking about, how you can call, let's say, an interactive command or an existing RPG program. And I just want to show you how seamless that is. And I don't know if this is a meaningful example, but let's say we're going to add another button to the screen. This is too big. Let's do a small one like this. And let's say we had a button over here that was going to go out and allow us to look at active jobs. So maybe not so realistic, but let's just see if we wanted the ability to go and work with active jobs off of the screen. How would you do this? So let's add a button. Let's give it a response of, we'll just call it active jobs. go to our code. So this is saved. We'll go to our code, and we'll just add over here some code that says if active jobs, if that button has been pressed, we're going to do something like run a command, which is the work active job command, just to see what that looks like and what this integration looks like. So let's just try it. Now we have the active jobs command. Of course, I am expecting the inquiry stuff to still work as it did before, but let's try clicking the active jobs button. And you can see that that took me to the work active jobs interface, and I am actually able to interact with it, page down, look at a specific job if I wanted to. And this is what Genie does for you. So you're actually flowing in and out of system commands, potentially RPG programs, and Node.js. So that's how the integration works here. So if I exit out of work active jobs, I'm going to jump right back into my product inquiry application. So that wraps up this particular demo, and the next one that I'm going to jump into is the conversion demo. What does it take to convert an existing RPG application? So let me bring up a green screen, and I'll show you an application that I've already converted, and we'll see what that looks like. So this is your typical green screen application. It has a subfile, and you're able to do things like put an option of 2 to change the record. And if I go back, there's also the option to delete the information. You have to confirm that on a screen and display the information. So very typical of what you might have in a green screen application. And of course, if we look at what this consists of, there's an RPG program here. So as you would expect, this is what drives the logic. And there's also a display file. That's the DDS that defines the green screen. So both of these pieces are going to be converted to get our ultimate output. Now, let's look at this RPG program and see what we have here. So first of all, you notice that it's fixed format. Of course, the process works just as well with free format as it does with fixed format. But what I want you to note is that this is more of an older style application, meaning it's more monolithic. We haven't split things up into service programs. We haven't used sub-procedures, and I'm sure a lot of you have code like that within your organizations. There's still some definition to it, and this is kind of key to this process. For example, you do have subroutines. Subroutines have the disadvantage that everything is in a global scope. It's still part of a much bigger program rather than these components, which is what we want. Ultimately, we want these components, but like we have this subroutine called load details, and it basically loads up a record and calculates some data that relates to those record details. But there's no way for us to reuse it right now, reuse just this piece of code, just this subroutine from the outside of this program. So this is one of the things that we're going to remedy by doing the conversion. So let me now show you what the output of the conversion looks like. So I'm going to go ahead and call up the menu where we've already converted this program and bring up the converted version of the application. And of course, you can see that right away. You see that on the user interface side, things look much nicer. And this is our rich display Profound UI user interface. Things like being able to scroll through the records makes it nicer. And my favorite is the fact that this becomes automatically searchable. So actually, you have features like this where you can go find and filter and sort the information. So you just start typing and it finds the records for you. So this is really neat, and no code has been written for this. This is just a grid feature, a client-side feature. You can just enable it, and you don't really have to write the actual code to go and search for that data. So that's available automatically on all the grids within this system. Let me then go into a specific record, and here we've added some capabilities. So again, these are not code changes or major code changes because the application is ultimately the same application as what we had before. But you can see that the function keys are now tabs. And let's look at this photo upload capability. So we've added some integration actually with Watson. We've added Watson integration. And if I look at what happens when I upload a photo, so let's pick another photo. Right now it's a flat tire. We're going to upload, let's say, this motorcycle. So what happens here is Watson has analyzed the photo, and it has actually determined, based on historical data, that it sees a motorcycle in there. So that's why the motorcycle involved flag automatically got checked. And if I go back and put the tire back in, it will analyze that photo and automatically check the flat tire. So this happens, it's pretty amazing actually, and this happens automatically. I didn't have to check the box. Watson was able to recognize this, and the reason I was able to do this in this particular case is because with IBM's Watson, they ship a very simple NPM package that makes using Watson very, very simple from your JavaScript code or from your Node.js code. So now that we've looked at this capability, I want to show you one more thing. So let's exit out of this, and I want to show you that we've actually modularized the program. And just to demonstrate this, I've got a little tool called Postman. Postman is your ability to run to test web services. So actually, this program is now web service accessible. So you can see that I've already ran here a little web service that basically sends in the claim ID, and it retrieves data about that particular claim. So we have this data here. So the way that works is that this is now a separate web service, and the user doesn't have to interact with the program. And in fact, we took a specific part of the program, the part that loads the details, and we were able to componentize that through this process. Let me just show you how this works. Now I know you can't, because the screen is so small, the send button here that I'm going to press is actually outside of the recorded screen, but I'm going to go ahead and press send, and I just put in a different claim ID, and you'll basically see that, okay, now it's going to come up with different information, so it's retrieving that particular claim. And let's go back to 1826, and it'll go out, call the web service, and retrieve this one. So pretty neat that you're able to do this, and how we've now componentized this particular application. So let me now show you the actual output, the actual converted code. And the way that I'll do this is by first bringing up the directory, the folder. So this is all being done in this demo lib directory, and because I have specified that I want to modularize, that's an option within the conversion process, it has created for me this another subfolder where all of the components are. So we've got the JSON file. This is what you'd expect. Now the real way to look at the JSON file, this is the definition of the screen, is to bring it up in the Visual Designer. So I can go ahead and show you what that looks like. So here's what the design view looks like, and it's basically the graphical interface. This the way that this came about is that there was an automated conversion of the DDS into this format, and there's a few enhancements that we went in and made. So for example, like we talked about, the tab panel was put in. That's just one of the widgets that you drag onto the interface. And of course there's also the file upload capability. This file upload capability here, I'm having trouble moving things around. So this file upload capability here, that's just another widget that we have that automatically takes in a file and puts it on the IFS. You're simply configuring this widget. There's really no code that's being written to actually upload the file. So that's the DDS converted into your JSON that renders as HTML5. And then let's start looking at the code. So I'm going to bring up, in an editor, I'm going to bring up, there we go. So this is the actual program, and some of the concepts that we talked about in my previous slides, you can see over here. This is how you, for example, execute a screen or write a record. Okay, so it is really the same logic as what we had before. The only thing is that it's kind of like more like free format. It's using JavaScript syntax, so we can kind of look through what's over here. It's no longer fixed format code. It's free format code. One of the things that you'll notice that is this program is actually much smaller now. So what's going on here? Well, it's because we have taken each one of the subroutines, and this was one of the options in the converter, something you can do, and we created a separate component. So let's now look at what those components are. So the components are in this subfolder, and you can see that it was able to say, okay, there's a separate routine that's for deleting, loading the details, creating a new record. And if I look at, let's say, the load details routine, you can see that it is a separate function in a separate file that is just being reused. So it's a small routine. Now the routine has dependencies. So if there were any fields within that routine that were only used by that routine, they would have been brought in and declared as local variables or local fields within this routine. But there's some fields that may be global, and the way that it treats them is it has to inject them, a dependency injection concept within Node.js. It works very simply. Now, you don't really have to, on your own, figure out, okay, what the dependencies are. This is something that the converter has done for you by creating all of these web services templates. So it knows what the dependencies are, and the dependencies are basically the input and the output of that subroutine. So if I go into this template for a web service for these load details, you can see that these are the dependencies. This routine uses the display file, this particular table, and this particular action field, and it can do all that independently of the main program. So this is a fully reusable web service that basically takes in a claim ID and then sends out the claim ID, description, total cost, and image file as output out of this particular routine. And because it starts out as a template, you can actually modify what kind of input and output that you want. But it imports and injects all the dependencies into this particular function that's defined in this file. So that's the key to this. This is how that type of thing works. So hopefully this gives you an idea of some of the capabilities of the converter. And so now I will take whatever questions that you have.